Hi everyone, in this video we'll discuss about merge sort. So merge sort is a sorting algorithm that is based on divide and conquer. So in this we divide the input array into two halves, then we call this function again for the two halves, and then we merge the two sorted halves. So in the divide and conquer algorithms, first we divide the larger problem into smaller problems. Then we solve the smaller problems individually and then combine all of them to give us the result. So merge sort is based on this programming paradigm. Let's take an example. So if we are given this input array which is of length 9 and we have to sort it using merge sort. So what we'll do is we'll split the array into two parts. So let's say this is the first part and this is the second part. And then we divide the first half also into two parts. So at each step of the algorithm, we'll keep on dividing the array into smaller parts. So once we are left with the smallest part, which cannot be further split into, then we'll start merging the two sorted halves. So in the first step, we have broken down the bigger array into two smaller chunks. Then we break the smaller chunks into further smaller chunks. So when we reach a stage when the array cannot be further broken down, then we start merging it. So in this approach, we divide the bigger problem into smaller subproblems, solve the smaller subproblems, and then combine their solution to reach the solution for the entire problem. So this is the divide and conquer algorithm, and the merge sort is based on this. Now once we have understood the concept on which merge sort is based, let's see the algorithm. So we have this function merge sort which takes the input array and two parameters low and high. So low will be the first index of the array and high will be the last index of the array. So initially low is equal to 0 and high is equal to 8 for this input array. Then the first condition that we check is if low is greater than equal to high. So this will be our terminating condition. So which means either low or high is pointing to the same element, or it is the end condition in which low has exceeded the high index. So in both of these cases, we would not do any operation and return from here. Because we are dividing the bigger problem into smaller problems, so first we need to compute the midpoint. So to compute the midpoint, we do mid equal to low plus high by 2. So low is 0 and high is 8. So in this step, the midpoint is 4. And then we call this function merge sort for low and mid. So if we write it down here, so in the first step, we call the function ms. So ms is merge sort and the parameters were passed as 0 and 8. So I've skipped the first parameter which is array because it is the same. So I'm just writing low and high. So from merge sort 0, 8 we call merge sort for 0, 4. So now low is 0 and high is 4. We again compute the midpoint. So midpoint becomes 2. Now we again call the merge sort function for low and mid. So we call the merge sort for 0, 2. So now high is 2. The midpoint becomes 0 plus 2 by 2 which is 1. And now we call the merge sort function for 0, 1. So low is 0, high is 1, midpoint is 0. So now we call the merge sort for 0, 0. So you can see at each step we are breaking down the array into two halves. So currently we are only dealing with the left half. So once low and high both are 0, so this condition is now true that low is greater than equal to high. So we return from here. So once we return from this point, then we call the function merge sort for mid plus 1, high. So mid at this step is 1. So from this function we call merge sort for 1, 1. When both low and high are 1, so this condition is again met that low is equal to high. So we return from this function. And now we call the function merge, in which we pass array low, mid and high. So for now, let's just assume that we have a function merge which merges the two sorted halves that are given to it. So we are calling the function merge with the parameters array. Low at this point is 0, mid is 0 and high is 1. So we are passing it two arrays. One is from 0 to 0 and the other is from 1 to 1. So what it does is this merge function, so it will have three parameters low, mid and high. So it will break the array into two parts. One array is from low to mid and other is from mid plus 1 to high. Low and mid both are pointing to 0 index and mid plus 1 and high both are pointing to 1 index. So 0 index is 150 and first index is 10. So this merge function will combine this 150 and 10 and sort it. So we'll see the implementation of merge in detail. So for now, let's just assume that this merge function will merge the two sorted halves. So when we pass it 150 and 10, it will sort them and merge them into 10 and 150 because this is the sorted order. Now we go back to merge sort 0, 2. So at this point, midpoint is 1. So we call merge sort 2, 2. So when low is equal to high, we return it. So this means after this, we call the function merge and we pass it low is 0, mid is 1 and high is 2. So we pass it 0, 1 and 2. So what this merge function will do is it will combine the two sorted arrays which are low to mid which is 0, 1 and mid plus 1 to high which is 2, 2. So basically the first three elements of the array will be sorted. Then we go back to this merge sort 0, 4. So now the call will be to the merge sort mid plus 1 to high. So at this point mid was 2. So the call will be to merge sort 3, 4. So merge sort 3, 4 will be again split into two parts. So the first call to the merge sort function will be for 3, 3 and the second call will be to the merge sort 4, 4 because midpoint of 3 and 4 is 3. So the merge sort 3, 3 and 4, 4 will be returned because low is equal to high. So merge sort 3, 3 will be returned and 4, 4 will be returned. And now the merge call will be done for low 3, mid 3 and high 4, which means this array from 65 to 90, so this will be sorted. So at this point the state of the array is 10, 45, 150 and 65, 90. So this is the first half of the array. So the first half which contains three elements, so these are sorted, and the second half which contains 65 and 90, these are sorted. So at this point this merge function will be called with the parameters low is 0, mid is 2 and high is 4. So this merge function will sort these two halves of the array and the sorted array will be 10, 45, 65, 90 and 150. So now first half of the entire array is sorted. So now we need to do the same operation for the second half. So second half contains 504, 14, 35. So when that is sorted, so that will be 14, 35 and 504. So now we have two halves of the array. First half is this 10, 45, 65, 90, 150 and the second half is 14, 35, 504. So now these both will be passed to the merge function and the merge function will have the parameters low is 0, mid is 4 and high is 8. So this merge function will combine the two sorted halves into the sorted array. So the sorted array will be obtained which is 1, 4, 10, 35, 45, 65, 90, 150 and 504. So the entire algorithm involves two steps. First, we break down the array into smaller chunks. We solve the smaller chunks and then we combine the sorted smaller chunks into the sorted array. So if we just write down how the values are sorted, so in the first step, we break the array into two parts. So now this part will again be split into 150, 10 and 45. This will again be split into 150 and 10. This will again be split into 150 and 10. And then these will be sorted. 150 and 10 will be sorted to 10 comma 150. Then this 45 will be here. And this 10 comma 150 will be combined with this 10, 150 and 45. So this will become 10, 45 and 150. And then we'll have 65 and 90. So these will be split into 65 and 90. These will be sorted and merged into 65 and 90. And this will be combined with 10, 45 and 150. So the array that we'll have is 10, 45, 65, 90 and 150. And now for the right half, we'll have 504 and 1. So these will be split into 504 and 1. So these will become 1 and 504. 4 comma 35 will be in the second half. These will be split into 4 and 35, which will be combined into 4 and 35 in the sorted order. And now these two will be combined into 1 comma 4 comma 35 comma 504. Now the left half and the right half will both be combined and merged into a sorted array, which will be our answer: 1, 4, 35, 45, 65, 90, 150 and 504. So the merge function will take two sorted arrays and combine them and give us a sorted output. So this is how the merge sort algorithm works. Now let's also have a look at how this merge operation, which takes two sorted arrays and gives us a sorted output. Let's see how this merge function works. So for explaining the merge algorithm, let's say we have two sorted halves. So the first half and the second half. So the second half that we have sorted, so this gives us 1, 4, 35 and 504, and the first half gives us 10, 45, 65, 90 and 150. So the low to the merge function is 0, mid is 4 and high is 8. So basically if we write it down, in place of 150 we have 10. So this is the right half and this is the left half. So this is low, 4 is mid and 8 is high. So this is the array that we have obtained after we have sorted the left half and the right half individually. Now this merge function will combine these left and right sorted halves into the complete array. So merge function combines sorted halves into one. So how we do is, first we create a temp array. So temp array is created equal to the size of the array. So this is the temp array that we have created, which is equal to the size of the original array. We keep three indices, I, j and k. So I is pointing to the low index. So I is initially at 0. J is pointing to mid plus 1. So j is at 5. And k is pointing to 0 index. So in the first step, we copy the elements from the original array. So this is the original array into the temp array. So while I is less than equal to mid and j is less than equal to high. So we are copying the elements from the both of the arrays, which is from low to mid and mid to high, into the temp array. So first we compare array of I with array of j. So basically we are comparing 10 with 1 because j is at here and I is here. So which of these is smaller? So smaller is j. So we keep 1 here and we increment the k index. So k is the index basically for the temp array. So k is 0. So now k will be here. Because we are filling the temp array, so we need an index for the temp array, and I and j are the indices for the first half and the second half array. So j will be incremented. So j will come at the next location. So j will come at 4. Now we again compare 4 with 10. So 4 is smaller, so 4 will come here, and k will be incremented and j will be incremented. So j will come at 35. In the next step, we will compare I and j. So 10 and 35 will be compared. So 10 will come here and I will be incremented. So I will come at 45. And now 35 and 45 will be compared. So 35 will come here and j will be pointing to 504. Now in the next step, we'll compare I and j. So now 45 will come because 45 is smaller than 504. So I will come at 65. And now we'll compare 65 and 504. So again 65 is smaller, so 65 will come here and I will be incremented. And in the next step we'll compare 90 and 504. So 90 will come here and I will come at 150. Now in this step we have 150 and 504. So 150 will come here and I will be incremented, so I will come at 5th location. So now in this step, if you see, I is now greater than mid. So this while loop will break because this while loop is for while I is less than equal to mid. So this while loop will break, and now we'll copy all the remaining elements from the left half and from the right half. So we'll check while I is less than equal to mid. So this condition is not true. And then we'll compare while j is less than equal to high. And we'll fill all the elements from the array into the temp. So 504 is left. So we'll fill 504 in this temp array. So we'll decrement the k. So now we have the sorted array in the temp. But we need to copy these elements from the temp array into the original array. So the last while loop is for that we copy all these temp elements into the original array. So this while loop is for that. So this merge function will be called many times whenever we have to combine two arrays. So this low will vary for all the indices, so it won't be 0. So what we are doing is we are copying the elements from the temp array to the original array with the index low plus k. So basically this merge function works in 3 steps. In the first step, we compare both the left half and the right half and copy the smaller element in the temp array. So here basically we are copying smaller in temp. So if any of the array finishes, then we break out of this loop and then we have these 2 loops to copy any remaining elements. So after this point, the temp array has the sorted elements, and this last while loop is to copy the elements from the temp array into the original array. So that is how this merge function works. So the entire algorithm of merge sort works in basically 3 steps. First, we split the array into 2. So we compute the midpoint. Then we recursively keep on calling the merge sort function for the first half and the second half. So we have these 2 lines where we call it for the first half, then we call it for the second half. And then we call this merge function, which basically has the input as 2 sorted halves and combines these 2 sorted halves into an array. So this is the entire working of the merge sort algorithm. Now once you've understood the algorithm, let's have a look at the important properties of merge sort. So the time complexity of merge sort is order of n log n. So why this is n log n is basically we are creating a balanced tree in the merge sort. So if we have an array of n elements, in each step we are breaking the array into 2 parts. So we have n split to n by 2, n by 2. Now n by 2 will be split to n by 4, n by 4. Now n by 4 will again be split into n by 8 and so on. So if we remember our discussion in the binary tree, so we know that the height of the tree is order of log n. And if we do the summation of the number of elements at each step, so these will be n by 2 plus n by 2, this will be n by 4 into 4 times n, this will also be n. And the height of the tree is n log n. So basically the computation required to sort the entire array will be order of n log n, where n is the effort required at each node and log n is the height of the tree. So this was regarding the time complexity. And regarding the space complexity, so merge sort is not an in-place algorithm. So we have seen that we take a temp array which is of size n equal to the original array. So the space complexity of merge sort is order of n. So merge sort is a stable algorithm, that is, it doesn't change the relative order of elements with equal keys. So if we have two elements which have the equal keys, then the merge sort doesn't change their order. So it is a stable algorithm. It is not an online algorithm because at each step we are computing the midpoint and then splitting them into left half and the right half. So it cannot sort a list as it receives it. So that means merge sort is an offline algorithm. So these were the important properties of merge sort. Now let's have a look at the implementation of merge sort. All the source code that I will be showing is available on my GitHub repository, link of which is present here and as well as in the description. Now let's have a look at the code. So in the main function I have this array which is of 9 elements. I pass this array to the merge sort function. The low is 0 and the high is the size minus 1, which is the last index. So the low index is 0 and the high index is size minus 1, which is the last index. In this function merge sort, I first check if low is greater than or equal to high, which means there is only one element, so which means we can return it. So this is the terminating condition. Then I compute the midpoint and I call the merge sort function first for the left half and then for the right half. So once the left and the right half are sorted, then I call the merge function to combine the left and the right sorted halves. In the merge sort function, first I create a temporary array which is equal to the size of the array. I create three variables I, j and k. I will point to the left half, j will point to the right half and k will point to the index in the temporary array. So first I compare the left and the right sub arrays and copy them to temp array. So after this loop ends, I copy all the remaining elements if there are any left, and then I copy the temp array into the original array. So after this entire function ends, then the sorted array will be in this vec and then I print it in the main function. Let's see the output of this program. So the input array was passed and it was sorted using the merge sort. So that was all for this video. If you have any doubts or suggestions, please leave in the comment section below. If you like my content, please do like, share and subscribe to my channel. It really motivates me to make more such content. And until next time, this is Sandeep Thapar signing off.